Okay, back to probability. Now we're going to talk about the or condition. Okay? So, let's say you've gone through this dating ritual, you found maybe an attractive and a wealthy man, and it wasn't quite what you figured because you couldn't hold a conversation, because you're an educated woman, and you're looking for someone who can hold a conversation for you. So you threw the whole attractive and wealthy thing out the door, and you go, look, I just want someone I can talk to, have a good educated conversation with. So you're looking for a man now who has either an A or a B average. A or B average. Okay? A or B. Now, when you're less picky, I'll take either this or that. You think the odds go up or down? Odds go up. You're picky, you got more choices, better probability. The only way you do that is by adding. So when we have or probabilities, the probability of an A average or the probability of a B average student, in the or condition, we add the probabilities. So the probability of A average is 0.091 and B average is 0.246. So if we add these together, we get 0.337 or 33.7% chances of meeting someone who has an A or B average. It increases your odds from both here and there. Okay? That is called the or condition. But there is something interesting about the or condition we have to take into account. We have to take into account a concept called mutual exclusiveness. These two probabilities are mutually exclusive. You cannot meet a single male who has both an A or a B average. This is called a mutually exclusive condition in the or condition, and we don't do anything to this probability. It stays just the way it is. But let's say you moved on, you had that wonderful conversation with this educated man, but you realize that you are still a little superficial, and you would like a man who is attractive and smart. A man who is attractive and an A student. Okay? So, do it the same way. Probability of attractive, or. We're going to switch this to or. I apologize, my mistake. They're either attractive or they're intelligent. Attractive or intelligent. Probability of attractive or probability of A student. Okay? So, if we remember the probability of attractive was 0.61, we're going to add that to the probability of A student, which is 0.091. When we do that, 0.091 versus 0.61 is 0.701, so that's a pretty whopping probability, 70% chance of finding someone like that. Problem is, these are not mutually exclusive events. One man can walk in that door, and they can be both attractive and an A student. In this case, in this non-mutually exclusive case, we have to subtract out that probability of happening. What is that probability of happening? Well, it's the probability of someone being attractive and A student. So the probability of attractive and A student is 0.61 times 0.091, and that is 0.056. So to do this properly, the true or condition here, because it is non-mutually exclusive, we have to take 0.701 and subtract 0.056, and we get 0.645. That is the true probability of the notion that the next person walking in the door will either be a male, attractive male, or a male who is an A student, because it's a non-mutually exclusive probability. That's the or condition.